Hi guys, welcome to another session with Sid. This is Sid, and today we're going to be looking at science. So learn with Sid on YouTube. Every day at 3:30 we do a live session. Today's session is going to be about the sun. So what you guys are going to be needing today is a piece of paper. So I've got myself a piece of paper over here. You're going to need a pencil. I've got myself a pencil over here and lots of felt tip pens. Now what we're going to be doing is exploring the sun and also what kind of radiation it gives out into space and especially to Earth. So I'm just going to set up on my phone so I can read your comments. So if you are watching live, guys, do give me a shout out. We are going to be doing some exciting drawings today of the sun and the Earth and the radiation that it's giving out. So the first thing that we need to note is that the sun is a big ball of gas. And it is basically a star, but it's our star in our solar system, and that's why we've given it a name. So there's loads of millions of stars in the universe, and if you want to find out more about stars and the sun in more detail, we are going to be doing a space science camp in 2 weeks' time that you can sign up to. I'm going to do 3 hours of learning about space. So that's going to be over the next 2 weeks. But today we're going to focus specifically on the electromagnetic spectrum and the energy that the sun is giving out. So let's first of all share with you my screen, my desk, so you guys can see what I'm doing over here. So I'm just going to adjust my camera slightly, and then I'm going to share. So let's see what we're going to be doing today. So if you haven't already got some paper, get some paper ready, get your felt tips ready, and we are going to be doing some drawings today. So my A4 piece of paper is here. We're going to start off first by using my pencil to draw a sun. So remember, the sun is huge. So we're going to draw a huge sun, and you can't even see all of it because it's all been kind of kicked off the edge there. And then I'm going to draw an earth over here. And again, I'm only going to draw half of the earth. So we have half the earth, and I'm going to draw some of the islands on here. Now I don't know the geography off by heart, but if you want to be exact, you guys could go and find what the countries are and draw them like they're meant to be looking like. Now what's really interesting is in our science club we were looking at this in terms of solar energy. Mine just looks like some blobs on a circle here. So you can make this look like proper countries. We were looking at solar energy. We found out that the equator, so the equator is the closest point to the sun, isn't actually the hottest part of the Earth. It receives the most sunlight, but it isn't actually the hottest. So that was really interesting. And it's the area around it that's really hot. And it's up to 12 degrees higher. So that was really interesting. So I'm going to get some felt tip pens now, and I'm going to color in my objects here. And as I'm doing that, I'm going to be talking you through some of the science behind what is going on in the sun. Right, so I think I'm going to use a highlighter for the sun to make it nice and colorful. And I'm going to use some blues and some greens. So I need to find a blue there for the earth. Okay, so I'm going to start with the highlighter. I'm going to color in the sun. You can use whatever color you like. And again, submit your entries in today by 6 o'clock to be featured in our submissions video. And we're going to see what you guys come up with. But I think you're going to have some amazing images for today's science session. So in the sun, we have a process in here which causes all the light and heat that we see. So we have hydrogen atoms turning into helium. Okay, through a process called fusion. So they fuse together. We have loads of hydrogen. Remember when we did the Big Bang session, we were talking about how hydrogen is the smallest atom in the entire universe because it's got one proton and it's got one electron. And what is happening is that all of that hydrogen that was left over from the Big Bang has formed into lots of different stars. So we've got the sun is one, and in that, the process is that the hydrogen is fusing to become helium. Now, helium is a bigger atom. It's got 2 protons and 2 neutrons and 2 electrons. So what we're going to do is, once I've colored that in, let me go faster. Let's color that in quickly. You can take your time making it look really nice and neat. I'm going to quickly do that, and I'm going to write some information in the sun. Okay, so I'm not going to go into too much detail in what's actually happening in the process, but if you want to find out more, this is going to be covered in the space session. So we're going to be on the space camp, the science camp. So in here, what we're going to be doing is writing some information about what's happening inside the sun and what is the process in which we get all this heat and light. Right, so where is my, I want to look for a black felt tip pen. Let's see if I can find one, or a dark one. So I found here, got a grey one. I'm sure I had a black. I've got so many felt tips. Let me just use a grey. Is that going to be dark enough? I think so. Or maybe even a blue. Let's use a blue. So in here, we have hydrogen. So this is how we write hydrogen. Hydrogen is one proton whizzing around one electron. So you'll see that this looks familiar from our Big Bang Theory session. And this is fusing. So we say the process is fusion. Okay. And we are producing helium atoms. Now, helium has got 2 protons, 2 neutrons, and 2 electrons. Now, in that process, we're releasing lots of heat and light and electromagnetic spectrum. So what is the electromagnetic spectrum? Well, the electromagnetic spectrum is a range of waves that we can detect. So there's waves which are very, very, very long, and they are also released from the sun. So these waves are really, really long, okay? And we call them radio waves. So here, these are radio waves. I'm going to write here radio waves. Now, we use radio waves to listen to radio, okay? So we've utilized that on Earth, but radio waves are also emitted from the sun. Now, I'm going to draw some solar flares over here. Solar flares, and could color this in, make it look really nice and colorful. So radio waves are emitted from the sun. And next, what we're going to have is, I'm going to change color. I'm going to draw the next bit. Next bit we have is slightly smaller waves now. Okay, they're not as wide. Now, these are microwaves. So I'm going to write microwaves over here. Okay, so we've got microwaves. Microwaves are also used in our microwaves. That's where we got the name from. So we're going to draw those here. Those are also released from the sun. Next, what we're going to have is infrared waves. So I'm going to use a red for this. So infrared is getting, the waves are getting, there's more waves. This actually looks brown. This is brown. Can you see the waves are getting smaller and smaller? As in they're getting closer. I'm getting more waves in here. I've got 1, 2 in. Here I've got 1, 2, 3. Here I've got 1, 2, 3, and a bit more. So we're getting closer to lots of tiny little waves. And I'm writing IR waves for infrared waves. And we're going to come back to that a bit later. Next, what we're going to have is visible light. So I'm going to use the orange for this. So this is the light that we see. So I'm going to draw lots of waves here. 1, 2, 3, 4, 5, 6. And we're going to say visible light. We'll come back to this in a second. Okay, next we've got something called ultraviolet light. So I'm going to use a different color for this one now. You can pick whatever colors you like. I'm going to use purple for this. And I'm going to draw more waves. So 1, 2, 3, 4, 5, 6, 7, 8. Loads of waves there. So I'm going to draw UV for ultraviolet. Okay, next I'm going to have X-rays. Let's see if I can find a black for this one. So X-rays. So we're going to do more waves for this one. Looks like it's coming off the Earth, but I'm just going to write X-rays. And finally, we're going to have something called gamma rays. So I'm going to use red for this one. And there's going to be so many waves now. Are you ready for this? So many waves coming out. Okay, so these are all the different types of radiation that our sun gives off. Gamma rays are really dangerous. They cause cancer. X-rays are dangerous as well. Like if you get an X-ray done, you have to stand, the doctor has to stand behind some shields to protect themselves. And we're going to have a talk about these 3 in the middle in particular. Okay, so what happens is all these radiation is given out from the sun. Okay, so all of this radiation is given off by this big massive sun over here, which is giving us heat and light, but it's also emitting harmful radiation. Okay, not all of this is useful for us. Some of it can cause so much harm. It can cause cancer. It can cause us to have all sorts of complications and issues. Now we're going to come to Earth and we're going to see what happens when that radiation reaches us. Okay, so let's color this sun in. And I want your drawings to look nice and colorful, guys. You can use lots of different colors for your waves, but show the difference in the wavelength of the different waves. So you can have big waves, you can have small waves for gamma rays. I'm coloring that in. There we go, that's my sun. You can also use red. You can use red and different shades of yellow to create lots of cool looking solar flares coming from your sun. Right, let's go to Earth and have a look at what's happening now on Earth. So here, I'm going to color in the land first of all. Let's color in our land. So all of these rays are coming towards us. So they're going through space and they're coming towards our planet. Now, what happens when they reach our planet? Well, our planet's really special. So Earth is very different from the other planets in the solar system because it has an atmosphere. Okay, so Earth is very, very special. If you look at some of the other planets, if you look at Venus, if you look at Mercury, if you look at Mars, they are not, you're not able to survive on them because of the fact that they lack an atmosphere. So our planet is very, very special. It has a layer of protection around that protects us from harmful rays from the sun. So what I'm going to do is I'm going to create a layer around the sun. Let's color, my blues run out. I'm going to color that in. So this is my water, my blue's running out. My light blue's running out. I don't want to use dark blue because it's going to look too dark. So I want you to color your Earth in, and then we're going to add a layer of shield around our planet. So it's like having a shield in front of us, okay? And our atmosphere is very, very important. Now we're damaging our atmosphere by the pollution that we cause. So we need to protect our atmosphere to make sure that it continues to protect us. So here we have got Earth. Now what we've got is we've got a layer of atmosphere around here. So if you get another color, maybe a gray, and we're gonna color that in. So this is our atmosphere. It protects us. It goes all the way around our Earth. Now what this does is it stops certain radiation from reaching us, okay? So the first radiation that it's stopping from reaching us is the really harmful gamma radiation. So this radiation can't reach our Earth. The next radiation it's stopping is X-rays. It's also stopping radio waves and microwaves. So 99% of the radiation that's reaching us is actually these three over here. It's infrared waves, visible light, and ultraviolet light. Those are the three that reach Earth. So what I'm going to do is I'm going to cross out the ones that don't reach Earth. So this one gets stopped, this one gets stopped, that one gets stopped, that one gets stopped. Okay, so the ones that reach Earth, 99% of them are these three over here. Okay, so are these actually good radiation or are these harmful as well? Well, infrared waves is the radiation that is helpful. Well, it warms us up. If we didn't have infrared waves, we wouldn't feel the sun's heat. So when we stand outside and we feel that heat of the sun, and we close our eyes and we're like, oh, that's nice. It's the infrared radiation that we're feeling, okay? So this is what provides heat from the sun, okay? But it's also dangerous. So even though this is passing through the atmosphere and it's warming us up as a planet, it's also dangerous. This can cause skin burns, okay? So it can burn your skin and it can also cause cataracts, which is why it's very important to get sunglasses when it's sunny to avoid looking directly at the light and for the light to stop. You need to get proper sunglasses, though, polarized sunglasses. So this stops, so sunglasses help you to protect against infrared waves. Now the sunburn, now in hot countries, what do people do? They cover up. So they will wear a layer of clothing over their skin and that will stop your skin from being burnt. Now, visible light is what we see. So this is the light that helps us see things. Now, we can't see infrared. We can't see ultraviolet. So this is responsible for our heat. So we can write over here. Let's see, I'm going to take, so this gives us heat. Okay, this gives us light. This enables us to see. So we can say light. And ultraviolet, right? So this one over here, this gives us a tan. So we can write over here, tan. But again, UV can be dangerous as well. Ultraviolet can be dangerous as well, because this can cause skin cancer. So when we put on sun cream, we are protecting ourselves against UV light. And it can also cause cataracts as well. So these three, even though they're good and sunlight is generally good for us, it can be dangerous as well, which is very important when you go outside, especially in sunny countries. Now, in the UK, we don't get that much sun because we're all the way up here. So our sunlight isn't reaching us as much as it is in other countries which are near the middle. But it's still important that when you're out in the sunlight, that you protect yourselves. So you wear sun cream, or you cover up your skin. So you wear long sleeves and you make sure that your skin's covered so you're not able to burn your skin or have any harmful radiation reach your skin. Okay, so the sunlight is, well, the sun's radiation is really important because it heats, it gives us light. People like being tanned. We're going to be talking more about this, more about the electromagnetic radiation in our light course. So that falls under light. We're going to talk more about the sun in our space course. So if you want to find out more information about those courses, do get in touch. Hope you've enjoyed today and let me know what you guys come up with. Now, before we go, we're going to add over here. Remember to add your names, because I forgot to add it on yesterday's work, your name and Science with Sid, hashtag Science with Sid. Submit your work in, and I look forward to seeing what you guys come up with. So let's see who's watching. We've got Adam, Musa, and Zaina are watching from Romford. Thank you guys for those of you that tuned in. And for those of you that say that sunlight is actually good for you, it is, but too much can be harmful too. So do protect yourself when you're out in the sunlight, and find out what these radiations are used for. So we've got loads of radiation that we've utilized on Earth that's used for lots of different things that we do on Earth. So you could find out what this is used for. But if you want to find out more information about the courses, get in touch. And tomorrow we're going to be looking at art. So I look forward to seeing you guys again at tomorrow's session. Bye, guys.